Okay, all right. Let's begin. Function transformation. So this is the next topic that we're doing. Function transformations. So there are three types of transformations that you need to know about in A levels: reflection, translation, and stretch. Reflection and translation I've done in O levels as well. Stretch is something new for you. Now there are only going to be two types of reflections: reflection in x-axis and reflection in y-axis. Okay, so if you have this triangle here on the left side, it can either be reflected in x-axis like this or y-axis like this. How would you describe this? You would say either reflection in x-axis, in y-axis if it's in y-axis, or you would say reflection with y-axis as the line of reflection. Do not write reflection along y-axis. That's not acceptable. So you can either write in the short form. In the short form, you would use the word in. Okay, reflection in y-axis or reflection in x-axis. Or to be safer, you can write it full like this: reflection with y-axis line of reflection, or reflection with x-axis as the line of reflection. Now, when it's reflection in y-axis, what happens is, if you've got this original figure, and that gets reflected to this, the movement of the points is horizontal, right? The movement is horizontal. If the movement is horizontal, we call this horizontal reflection. When it's reflection in x-axis, the movement of these points is vertical, so we say this is a vertical reflection. So reflection in y-axis, we will be calling this horizontal reflection. Reflection in x-axis, we'll be calling this vertical reflection, because horizontal reflection means the direction in which you've got the points moving. Okay, now that's something that you understand in this. Y-axis, when that's the line of reflection, it's horizontal reflection. When x-axis, the line of reflection, that's vertical reflection. These are two types of reflection that you need to know about. Then you've got translation. There are two types of translation that you need to know about: horizontal translation and vertical translation. In this case, you will always have to write down vector. So if you have a point, if you have a triangle that's going from ABC to this transformed figure, A double dash B double dash C double dash, what's the translation vector for that? It's going 1 unit left and 1, 2, 3, 4, 4 units up. The translation vector is going to be -1, 4. -1 means you're going 1 unit to the left. 4 means you're going 4 units up. 4 units up. Now, for describing a translation, you always write down a vector. You cannot write this in words. You always have to write down a vector. That's necessary. Now, these are two transformations that you already know about from before, from O levels as well. Then there's one new transformation, that's stretch. How does stretch work? There are two types of stretch that you have in the syllabus: vertical stretch and horizontal stretch. In vertical stretch, what happens is you see the distance from the x-axis. If the scale factor is 3, for instance, the stretch works like this. Every point, whatever its distance was before, it becomes 3 times that distance. For example, if you have this point C, this point C has a distance of 1 unit from the x-axis. After transformation, what happens is it becomes 3 units from the x-axis. That's a stretch with scale factor 3. For B, the distance was 2 units from the x-axis. After transformation, what happens is it becomes 2 times 3, and that becomes 6 units. That's a vertical stretch when the y coordinates get multiplied by the scale factor. If it's a scale factor of 3, then you say whatever was the y coordinate before, it gets multiplied by the scale factor. You can have a horizontal stretch as well. In horizontal stretch, you think about the distance from the vertical axis, distance from the y-axis. So, for example, if ABC, this was the original figure, and you want to stretch this by a scale factor of -1/2, what would you do for that? You would say B point is 3 units away. You multiply that 3 by -1/2, and that becomes -3/2. That's where the point B is going to be. Right. Similarly, for A, this point is at a distance of 1 unit to the right side. If it's stretched by a scale factor of -1/2, what happens is the x coordinate 1, it gets multiplied by -1/2 and it goes here. And that's how stretch works. So all you have to do is in case of vertical stretch, multiply the y coordinate by that number. In case of horizontal stretch, multiply the x coordinate by that number. And that's how the graph moves. Your figure becomes bigger in one direction. If it's a vertical stretch, you will see that the height of the figure will change. If it's a horizontal stretch, you would see that the base, that the width of the figure, that's going to change. So it was 3 earlier, it becomes 1.5 like this, right? So if it's a vertical stretch, the height changes. If it's a horizontal stretch, the width of the graph changes. Now, these are three transformations that you have. How do you describe these transformations? You have to describe these in exactly one of these ways. Exactly one of these ways. So there are three types of transformations. First of all, you've got reflection. We talked about this before as well. Either say reflection in x-axis or reflection with the x-axis of the line of reflection. Similarly for the y-axis, this is vertical reflection because the movement of the graph is vertical. Then you've got translation. You have to write down the translation vector for this. If it's a vertical translation, you have something in the y component here. If it's a horizontal transformation, you have something in the x component here. For stretch, you always describe it like this. If it's a vertical stretch, you either say it's a vertical stretch with scale factor something. If it's a horizontal stretch, you say horizontal stretch with some scale factor. Another way to describe this is you say for vertical stretch, it's a stretch along x-axis, with that scale factor. And similarly for the horizontal stretch. Or you can say stretch parallel to y-axis for vertical and stretch parallel to x-axis for horizontal. These are the only three descriptions that you can have for stretch. Don't write anything apart from these three, okay? Just one of these three. Don't write multiple. If one of them is wrong and the other is correct, that will be marked wrong. So just write one of these, whichever we are most sure about. You can write just vertical or horizontal, and that will be fine as well. Or you say either stretch along that axis or parallel to that axis. In reflection, do not use along. If you want to write it in short form, use in, or just say it's a reflection with that line as the line of reflection. Okay, that's how you describe these transformations. So you've got 6 transformations in total here. 3 vertical, 3 horizontal. In vertical, y coordinates change and horizontal x coordinates change. Now, how is that relevant to functions, right? These are transformations. How do they relate to functions? So basically what can happen is you may have a function f of x and it can have something multiplied or a minus sign multiplied or something adding or something added or subtracted outside. When you have something like this, something adding or subtracting outside, minus multiplying outside, or a number multiplying outside, these are vertical transformations. The y coordinate changes because of that, because you're multiplying something with f of x, right? The y changes. In vertical transformations, the graph moves in the vertical direction. Only the y coordinates change, and the operations, some operations are applied outside the function, either plus minus, multiplication with negative, or multiplication with a number. These are 3 things that can happen. When you multiply by the negative sign, that means it's a reflection with x-axis as the line of reflection. If you had points x and y, since the movement of the points is vertical, the point that was above that goes down, the point that was down that goes up. So the y coordinate changes, plus y becomes minus y, right? The sign of the y coordinate changes, x coordinate remains the same. What about this number that's multiplying? When you have a number multiplying outside the function, that means it's a stretch along the y-axis, or you can say vertical stretch with scale factor, that number, which is a. So if you have xy as the original point, that becomes x, a, y. The y coordinate gets multiplied by that scale factor. And if you have something adding or subtracting outside, if you have plus or minus something, that's a translation, that's a vertical translation. Plus means you're going up, minus means you're going down. Okay. And if you have a point xy, that becomes x, y plus minus b. The y coordinate has b added or subtracted like this. Then you have some horizontal transformation. In horizontal transformation, what happens is operations are applied inside the function. And the graph moves horizontally and only the x coordinates change. Instead of outside the function, you've got something happening to x inside, x plus minus something, or minus into x, or a into x, right? Now, these are the 3 transformations that you've got. You can have something, You can have minus multiplied outside, minus multiplied with x. What does that mean? It's a reflection with y-axis, the line of reflection. It's horizontal reflection. So the x coordinate changes, x becomes minus x, y remains the same. When you multiply by 8 here, you multiply by a number. That's a stretch. That's a horizontal stretch, or you can say stretch along x-axis with scale factor reciprocal of this number. So in horizontal transformations, things work a bit counterintuitive. When you multiply by a number, it's basically a compression. So the scale factor of the stretch is going to be reciprocal of that. That's 1 over a. So what happens to the coordinates? If the original coordinate was x, y, it becomes x over a. X is divided by that scale factor. X is divided by that scale factor. And then for a translation, if you have plus minus b, what happens in this case is when you have a plus in the function, you go left. When you have a minus in the function, you go right. Okay. Now the translation vector, what is that going to look like? If you have plus here, in the translation vector, you would have minus. And when you have minus here in the translation vector, you would have plus, because plus in the function means you're going left, minus in the function means you're right. You're going right. So for example, if you have something like this, f of x plus 3, that means it's a translation, 3 units to the left, the vector is going to be minus 3, 0 for this like this. Okay, that's what happens in horizontal transformation. When you add or subtract something, that's translation. Outside the function vertical, inside the function horizontal. When you multiply, divide by a number, that's a stretch. If you do outside the function, that's vertical. Inside the function, that's horizontal. When you multiply by -1, that's a reflection. When you do outside the function, that's vertical reflection. When you do inside the function, that's horizontal reflection. These are 6 transformations that you've got. Now, this is very important, order of transformations. So sometimes you can have multiple transformations happening at the same time. So when you have only one transformation, describing that is straightforward. Okay. But when you have multiple transformations, in that case, the order is important. You have to apply those transformations in the correct order. Now, how do you figure out what the order is? When you have horizontal and vertical transformations, some horizontal and some vertical, in that case, the order does not matter. You can do horizontal first, you can do vertical first. It does not matter. Both of them have because the horizontal transformations are only going to change the x coordinates. Vertical transformation is only going to change the y coordinate. So they don't have anything to do with each other. You can do any of them first and that will be fine. When you have multiple vertical transformations, for example, when you have something like this, -2 of f of x plus 7, or let's just stick this for now, -2 into f of x plus 7, what you do in vertical transformations is you follow BODMAS. Whatever BODMAS says, that's the order that you follow for transformations. Now, BODMAS says you do multiplication first. So that means you do stretch or reflection first, right? -2, that's multiplied. So you do this first, and then you do translation. So you do +7 later on after that. However, if it looks like this, when they have an extra bracket sometimes like this, and that happens a lot in recent papers, when they have extra brackets like this, what that means is, now BODMAS says bracket gets evaluated first. So +7 has to happen first. So that means in this case, you do translation first. It's a translation 0, 7 first, and then number 2, you do the stretch after that, and reflection after that. Right? Stretch and reflection, they have the same priority. Between them, it doesn't matter which one you do first, but translation in the second case happens first because that's what BODMAS says. And in the first case, translation happens second because that's what BODMAS says. In vertical transformation, you just have to follow BODMAS. In horizontal, however, you just do the opposite of that. You do opposite of BODMAS. Whatever BODMAS says, you do the opposite of that. So for example, in this case, you have f of -5x plus 3. Now, what does BODMAS say? BODMAS says that you would multiply by -5 first and then add 3. In horizontal, you do the opposite. You say, no, you'll do this first. That means you apply that translation first. And then after that, you do stretch. Okay. If you have something like this, that's the most complicated, the most confusing one. So you have f of -2 into x plus 4. What do you do in this case? Again, this is horizontal transformation because something is happening inside the function. You're doing something to x. Now, what does BODMAS say? Because of this extra bracket, BODMAS says that you would do +4, and then you would multiply by -2, but this is horizontal transformation, you'll do the opposite of that. You'll say multiply by -2 first. That means do stretch reflection first and then do translation. So in horizontal transformations, you just have to do opposite to whatever BODMAS is. That's the order. That's the way you figure out the order of transformations. Okay. Now, for instance, if you had 2 into f of 3x, look at the first example. You've got one vertical, one horizontal. It does not matter which one you do first. You could do this first, you could do this first. It does not matter because between them, we don't care which one we do first because horizontal only change x, vertical only change y. If you have multiple vertical transformations like this, -4 and then the +1, in this case, you do stretch and reflection first. Or you can just say it's a stretch with scale factor -4. That's also fine. And then you say it's a translation after that. That happens second. In this case, the order matters. That's important. When you have horizontal transformations multiple, f of -6, -2, -6 is -2, you do the opposite of BODMAS. That means you have to do translation first, and then you do stretch or reflection after that. That happens second because that's the opposite of BODMAS. Sometimes you can have all of this happening at the same time, like this. You've got all vertical transformations, all horizontal transformations. What's the order going to be? You can start with either horizontal or vertical. That would not matter. You can start with either horizontal or vertical. It would not matter. So let's start with vertical, for instance. In vertical, you have to do stretch first in this case, because that's what BODMAS says. You do stretch first. And then you do this translation that's 0, 2. And then you can start with horizontal. In horizontal, you do translation first in this case, because opposite to BODMAS, that's 1, 0 translation, and then stretch scale factor -1/4. Now, when you have multiple transformations like this, and you have two translations coming one after the other, it's also possible to combine them as a single transformation and single translation, and you can say 2 and 3 could be combined to give 1, 2, and that will also be acceptable. Okay. However, if you had another transformation between these two translations, then you could not combine them. Then that would not be allowed. But if two translations are coming one after the other, then it's possible to combine them and write them as a single translation as well, and that will be fine. Y equals x, reflection in line y equals x, we do that when we have a function and its inverse, but we don't consider that in function transformations. The only place where that is relevant is when we have a function and its inverse function. So we don't study that in function transformations here. Let's look at this example. If you have a function f of x equals x squared, and it's being transformed to this function g of x, and we have to describe the transformations that are happening. How do we describe these transformations? So we've got two vertical transformations. X squared was the function, right? Outside the square, we've got two things happening. We've got 2 multiplying, and outside the square, we've got 3 adding. Which one do we do first? We apply BODMAS. BODMAS says, because this is vertical transformation, right? We apply BODMAS here. So BODMAS says you do +3 first. So you do translation, vertical translation. In this case, I've written horizontal first. It doesn't matter. Between horizontal and vertical, it doesn't matter. Let's start with horizontal first. This can come at any place. It would not matter because there's only one horizontal transformation, and that's this -2. That's a translation 2, 0. Okay, so that's one translation that's happening. But then vertical transformations are 2 here. This is one vertical transformation. This is another. So in this case, between those two, the order does matter. So you do translation first in this case because that's what BODMAS says, 0, 3, and then you do vertical stretch, scale factor 2. Now this is one way of describing this. You could also say, this is an actual exam question, this particular function. Another way to think about this could be that you simplify this expression first of all. And you say, let's simplify g of x in a way that this 2 gets multiplied with this and this, so that the bracket opens and you write it like this. And now if you do it like this, you can say it's a horizontal translation 2, 0. That's the same as before. But vertically, now since there's no extra bracket there, you do multiplication here first, and then you do addition. So that means now you can say it's a vertical stretch scale factor 2, and then it's a vertical translation that's 0, 6. And that's also acceptable. These two are equivalent to each other. Even though these vertical translations that you have now, they're different, but since the order is changing, that takes care of that. So these two are equivalent. You can either do it the way on the right side or on the left side. Both of them are equivalent to each other. Now, when you have quadratic functions, so this is how you apply transformation, right? This is how the order of transformation works. This is the easier part, that you are given some transformation and you have to describe that. Okay, that's relatively easier to do. The difficult thing normally is that you have to identify the transformations yourself. In this case, though, we're doing that as well. So let me show you that example. Okay, so this is what I'm talking about. So sometimes what they do is they give you something like this. They give you equations like this. Y equals x squared plus 2x minus 5. And they say it's transformed to this. Figure out the transformation. So this is normally the tricky part. How do you understand how to go from this to this? So normally when they give you quadratic functions, you should always complete the square for those functions first. That will make it easier for you to spot those transformations. Okay, so whenever you have a quadratic function and you need to describe the transformations, as in identify what transformations are happening to go from one function to another function, first complete the square, and that will help you identify what transformations are happening there. Okay, so that's another important thing. Now, let's have a look at some examples, because that's where people get confused. The concepts are not that difficult, but its questions are a bit tricky sometimes. Let's have a look at this. This is a very straightforward example. First up, we've got this function f of x, and this is transformed to this. What kind of transformation is that? That's a reflection in the line y-axis. Now you have to be careful. Is it a horizontal reflection or vertical reflection? It's a horizontal reflection because the movement of the graph is horizontal. We want to write down the function f, the equation of this graph in terms of the function f. F was the original function. What's the equation of this transformed graph? This is horizontal reflection. That means inside the function, we will multiply with minus. So that's f of minus x like this. What about this now? You've got this original graph, and that's being transformed to this. Now, stretch is the easiest to spot, because not the easiest, but it's like very easy to spot because you would always have the size of the figure changing, right? In this case, you can see vertically, the height of the figure is changing. It was 2 earlier, now it's becoming 4, right? Horizontally, however, there's no size change in size. There's only one. It was 2 earlier. After that as well, it's 2. So it's a vertical stretch. It's a vertical stretch by what scale factor? Height was 2 earlier. Then it becomes 4. So it's multiplying by 2. So what's the function that we have here? We say this is 2 times f of x. Now, there's no translation here. When you do stretch, the points automatically move up because of that, because this was 1 unit. After stretch, it becomes 2 units, so it moves up. This point was 2 units up. After stretch, it becomes 4 units up. So there's no extra translation that's happening. It's the stretch that is moving this graph vertically upwards as well, because the y coordinates are getting multiplied by 2. So this is 2 times f of x. That's a vertical stretch by scale factor 2. Think about this. You've got this original function. It's being transformed to this. Now, that's clearly a translation. The graph is shifting from one point to another. How many units to the left? 1, 2, 3. 3 units, and then 4 units left. So that's minus 4. And then 1, 2, 3, 3 units down. So the translation vector for this is going to be minus 4 and minus 3. 4 left and 4 down. However, we are not looking for translation vector. We want the equation of this function in terms of f of something. How do we write that now? Translation is when you have plus minus something. Now, minus 3 is a vertical translation. So we have minus 3 outside the function. Horizontally, the graph is going 4 units left. Left means inside the function, you would have plus. So inside the function, it will be f of x plus 4, right? In horizontal, things work a bit counterintuitive. Plus means left, minus means right. Okay. So when you're going left, inside the function notation, you'll say it's plus 4. And that's what the function becomes in this case. Let's look at this. Now, you have to describe the transformation that takes you from this graph to this graph. Now, whenever you have to identify transformations, always think of stretch first. Always think of identifying the stretch first, because that's going to be very clear to spot in that case. As in, you can't be wrong with that, because you know exactly what stretch is happening just by looking at the figure. Look at the width, that's not changing, so there's no horizontal stretch that's happening. But vertically, the height was 1 earlier, afterwards it becomes 3. So you know for sure it's a stretch by scale factor 3. So when you have to identify transformations from a diagram, always identify the stretch first and clearly show that on the diagram. And then think of the next transformation. So in this case, we have figured out that, okay, this has to be a vertical stretch scale factor 3. Stretch along y-axis, scale factor 3. That is definitely there. Okay. Now, you don't think of the next transformation until you have sketched the result that you would get from this first transformation. So when you stretch this figure by a factor of 3 in the vertical direction, this point goes here. Sorry, this point goes here. 1 goes to 3. The point at 2 goes to 6. So that's here. And this point at 2 goes here. And after that stretch, the figure comes here. Now, when it comes here, now you think of what further you have to do to this to take it to this graph now. Now, that's a translation just 4 units to the right, and that's what you write down. It's a stretch along y-axis scale factor 3 and a translation of 4, 0. If you do not draw this intermediate step, this step, you would wrongly think that there is a vertical translation happening as well. That's not happening. The vertical movement is because of the stretch itself. So when you show what happens after that stretch, it becomes easier to spot what the next transformation is going to be after that. That's just a horizontal translation. There's no vertical translation after that. Okay, and then you have to write down that function in terms of f of x. So that's what it becomes. 3, that's a vertical stretch, and then -4 inside because it's 4 units right. That means inside the function you do -4. Another very similar example, you have to spot this transformation. This is the original graph. Let me share that for you. This is the original graph, the highlighted one. And this is going to become this dotted graph. Now, how do you figure out what transformations are happening? Again, the first thing you should think about is what stretch is happening. Then think about any other transformation. What stretch is happening? Is there any horizontal stretch? Horizontally, it's 4 units afterwards, and it's 4 units before. There's no horizontal stretch. Vertically, however, it's 2 units before, and it becomes 4 units afterwards. So it's a vertical stretch, scale factor 2. That's what you write down first. You say it's a vertical stretch, scale factor 2. First of all, do that stretch. When you apply that stretch, you get a figure like this. So this was the original graph. The green one is the original graph. After applying stretch, you get this yellow graph. After applying the stretch, you get this yellow graph. Now that you've done that, now you think of what further you have to do to this yellow graph to get to that dotted graph. Okay. Now, there could be multiple ways of thinking about this. Now, you could say, let's go 1 unit to the right. There are 3 transformations, right? So you can say, go 1 unit right, and then do a reflection in y-axis. Or you can say, do a reflection first, so that you get this green graph, and then you go 1 unit left. So after you've applied that stretch, then identifying the next transformation becomes quite straightforward. So this is what you get. This is one way to describe this. There are other possibilities as well. Stretch is definitely going to be this, but apart from stretch, the other transformations, they could be described in other ways as well. This is one way to do this. You say you reflect in y-axis, and then you have a translation -1, 0. And then you have to express g of x in terms of f of x, as in the transformed function was g of x. Express that in terms of the function f, the original function. How do you do that? It's a stretch in the y direction, scale factor 2, so you multiply by 2 outside. The reflection in y-axis, that's a horizontal reflection. When you reflect in y-axis, that's a horizontal reflection. So you multiply by -x inside. That's happening first, right? So you multiply by -x first inside the function. And then, once you have that, you do this translation. Translation is -1, 0. What does that mean? You replace x with x plus 1. put that inside bracket because you have a negative outside. Inside bracket, you would say x gets replaced with x plus 1 because that's what this translation means. Then you simplify that. That's the result that you get. 2f of minus x minus 1. That's the function g of x in this form. Okay, this is a good example. Have a look at this later on as well. Try to think about this again. Let's move on. Let's have a look at this now. Find a translation that transforms the graph this to this. How do we think about this now? So you've got 5 over x squared minus 3x, and it's transformed to this graph. Now, just by looking at it, you might get the wrong idea first that it's a horizontal translation of 2 units, right? Because it's going from f of x to f of x minus 2. So you say it's a translation of 2 units, right? And there's a plus 10 outside. So that's 210 translation, right? That's what you would think of at first. If you do it in a hurry, you would get 210 from this. But that's not correct. That's not correct because even though this x is going and becoming x minus 2, what about the other x? If you go from f of x to f of x minus 2, every x should be replaced with x minus 2. The other x is staying x. That's not changing. So again, that's why it's important to do it step by step. What's the transformation that you're very sure about? X is becoming x minus 2. Inside the square, we can say that, okay, this is becoming x minus 2. Apply that transformation first. That, okay, f of x is going to f of x minus 2. Apply that transformation, and that gives you this. So you replace x with x minus 2, and you get a function like this. Replace x with x minus 2 here, replace x with x minus 2 here. Now you simplify this. After simplification, you already have a plus 6 outside like this. After doing that horizontal translation, you already have a plus 6 outside. And then you think of how much more do we need to add here to get to that point 10? You have to add plus 4, and that gives you a vertical translation of only 4 and not 10, and the translation vector turns out to be 2, 4. So when you have to identify transformations, do it step by step. Write down the transformation that you're very sure about first. Apply that transformation and see, okay, what happens after that? Okay, otherwise you can often get wrong results. Let's have a look at this. It says the curve with this equation is translated by minus 1, 3. Find the equation of the translated curve, giving an answer in the form y equals ax squared plus bx plus c. Now, this is just an application of a transformation. The transformation is already given. It's minus 1, 3. What that means is if you had the function f of x, that would become f of x plus 1 plus 3. Inside the function, you have plus 1 because of this horizontal transformation. Outside the function, you've got plus 3 because of that vertical translation. All you have to do is just replace x with x plus 1 here, and outside the whole thing, have a plus 3, and then simplify that. Completing square in this case is not necessary because you had the transformations given and you just had to apply them. But when you have to identify the transformation, for example, in the second part now, you've got this equation, and it's transformed to this equation. Describe fully the single transformation that has been applied to go from this step to this step. Now, how do you think about this? Okay, let me actually come back to that example in a moment. Let me do this first of all. I'll go back to that because that this single transformation, that there's another complication here. Let's do this one first before that. We've got this f of x function, that's x squared minus 2x plus 5. This is another function, g of x equals x squared plus 4x plus 13. We have to figure out what transformation transforms the graph of y equals f of x to the graph of y equals g of x. How do you go from this graph to this graph? How do you identify this transformation? You should first complete the squares. Otherwise, it will become difficult to identify the transformations. It will not be clear. This is x squared minus 2x plus 5. When you complete the square, it becomes x minus 1 whole squared plus 4. And then the final result is x squared plus 4x plus 13. When you complete the square, it becomes this x plus 2 whole squared plus 9. And now you can look at this. What is changing in these functions? Outside the function, plus 4 is going to plus 9. What do you have to do to go from 4 to 9? You have to add 5. You have to do plus 5. And that gets you to this final result. To plus 5 outside. And then what else? Inside the function, you have minus 1 right now. That has to become plus 2. How do you go from minus 1 to plus 2? How much do you have to add? You have to add 3. You have to do plus 3. So inside the function, you say It's f of x plus 3. What transformation is that? You have to describe this transformation. Plus 5 means the vertical translation, 0, 5. Plus 3 means it's a horizontal translation, minus 3, 0. When you combine them, it becomes minus 3, 5. That's the transformation that you've got. It's a translation, minus 3, 5. It's very difficult to spot directly from this unless you complete the square first. So when you have quadratic function, then you have to identify the transformations, complete the square first, and that will help you understand that better. Sometimes when they say it's a single transformation, in that case, it is sometimes possible to do it directly as well, but you have to think a bit about that. For example, in this case, you've got this function x squared plus 2x minus 5, and another function 4x squared plus 4x minus 5. The function on the left side is being transformed to the function on the right side. Now, what transformation is this? You can think about this in your head as well. Minus 5, minus 5. The constant is not changing. That's remaining the same. That means if anything was applying to the whole function, then this constant would also change. This is not changing. So this is not a vertical transformation, right? Because in vertical transformation, the whole function changes. In this case, minus 5 is remaining the same. That's not changing. So that means it has to be a horizontal transformation. Now, what transformation? X squared is becoming 4x squared. So that looks like something is getting multiplied. And 2x is becoming 4 times x. Something is multiplying. So it's horizontal. We figured that out. And something is multiplying. What transformation is it when we multiply something? That's a stretch. Now, what do you multiply x by? If you think about it, 2x is becoming 4x. You're basically multiplying by 2 here. X squared, if you replace that with 2x whole squared, that becomes 4x squared. So yes, that's what is happening. You have f of x going to f of 2x. So that's a vertical stretch. That's a horizontal stretch. Scale factor 1 over 2. Okay. Sometimes you can identify it directly, but in very rare cases, when it's a single transformation, you can think about it in your head as well. But when it's multiple transformations, you cannot do it directly. You have to complete the square for that necessarily. Okay, this is an alternative method for that. If you were to do it using completing square method, in this case, it's a bit long, but you can have a look at this. It gives the same result eventually. Okay. Let's move on. Now, you have transformations in trigonometry as well. These are sometimes a bit tricky. Let's have a look at this example. So you've got this original curve. This is the graph of y equals cos theta. Okay, and this is being transformed to the upper curve, this curve here. They are saying, find in terms of a cosine function, the equation of the upper curve. What's the equation of this curve? How do you figure that out? Now, what's the baseline of the original graph? It's the x-axis. What's the baseline of this graph? How do you identify that? The maximum point that you have here is 5. The minimum point on this graph is 1. Where is the baseline going to be? The baseline is going to be in the middle. That's at the point 3. So that means the baseline is going up. The baseline is going up by 3 units. What does that mean? It's a translation. It's a vertical translation by 3 units up. So you would say that becomes cos of theta plus 3. That's one thing that's definitely happening. Okay, so baseline is moving. What about the amplitude? Is that changing? Just think about that. The amplitude earlier was 1. Now the baseline becomes this at 3. What about the amplitude now? That's 2. So amplitude is becoming twice. That means the vertical stretch, scale factor 2. So we multiply by 2 outside. It becomes 2 cos of theta plus 3. What else? Is there anything changing horizontally? Is there anything changing horizontally? Is the period changing? Is the graph shifting left, right? The period is clearly changing. It's completing 2 cycles in 4 pi. In fact, let's consider 2 pi, the standard period. In 2 pi, this is 1 cycle, right? This is 1 full graph. The period for the transformed graph has doubled. It has become twice. It was 2 pi earlier for the original graph. The period is 2 pi. For the transformed graph, the period becomes 4 pi. The period is becoming double. When period becomes double, that means it's a stretched scale factor 2. If scale factor is 2, you've got half theta here. This is going to be half theta. Okay. Yes. So sometimes it's easy to figure out these two transformations. the vertical transformations. Horizontal, some people find it a bit difficult. One way to do that is that once you figure out these two transformations, then you could say this is 2 cos of a theta plus 3, and then input some value there, and for take some value on the graph. For example, at 0 it's 5. See if that works. If that gives you a value, for it, 0 will not give you a value because a will get eliminated. But take another value, for example, at 2 pi it's 1. Input that and find the value of a from that. That's longer. You can do that. If nothing else works, then yes, you can do that. But it's much easier and much quicker to understand transformations well. Since the period is getting double, that means it's a stretch scale factor 2. It's a horizontal stretch scale factor 2. If the scale factor is 2, inside here we have it divided by 2 like this. You can also understand this in terms of the period of the graph. The period is becoming, so the original period is, so this is the equation that we can use for this. The new period of the graph, the period of the transformed graph, it's always equal to the original period divided by that number that's multiplying. So let's say this number is b. You can just input values in this formula. Original period of a cos graph, what's that? In radians, that's 2 pi. The period of this transformed graph, that's 4 pi. Find the value of b from that. That turns out to be 2, and that's what that turns out to be 1 over 2, and that's what we were looking for. Okay. If you cannot think of it in your head directly, you can use this equation, and that will give you the value for b as well. All right, let's take another example on this. If you have a tan function like this, what about this now? For tan, there's no amplitude as such. What about the baseline? What did I tell you about the baseline of the tan function? It says the diagram shows the graph of this function, a tan of x minus b plus c. How do you figure out the values of a, b, and c from this? For a tan function, the baseline is when the direction of the graph is changing. So look at this graph. It's going in this direction, and then it changes its direction like this. So where's the baseline? Baseline is at this point here. That's where the direction is changing. If you look closely, that's the point where the direction is changing. So that's the baseline of this graph. Now, if this is the baseline, that's 1. So you say this number outside, plus minus, the graph is shifted upwards, right, by 1 unit. The original tan graph, it has its baseline at 0. So it looks like this, right? The original tan graph. Its baseline is at this point. That is moved 1 unit up. That's translation, vertical translation, 1 unit up. So you have this plus 1 outside. The value for c, therefore, is equal to 1. Okay, what else? Is there any stretch that is happening? Look at the horizontal direction. What's the period of this graph? What's the period of this graph? Period of the original tan graph is pi radian. What about the period of this graph? This is completing one full cycle from minus pi over 4 to 3 pi over 4. What's that distance? 3 pi over 4 minus pi over 4, that's pi radian. Is the period changing? No, period is not changing. So original period was pi, this is also pi. So period is not changing. Okay, period is not changing. What else is changing? The graph is shifted. Original tan graph, what does that look like? Original tan graph looks like this. It starts from 0 and it goes like this. Right? That's the original tan graph. It looks like this. Now, we have figured out that it's moving 1 unit up. So that would have moved somewhere here. After moving 1 unit up, it'll look like this. But then this point, where is that going? That's going here. What's that? That's a translation. Pi over 4 units to the right. Pi over 4 units to the right, that's a translation. That means this number here, b, that has to be pi over 4. It's the minus sign. Minus means you're going right in horizontal transformations. So that number is therefore pi over 4 because you're moving pi over 4 units to the right like this. Now, what else? What about the number outside? They're saying there is a vertical stretch there as well. What vertical stretch? How do you figure that out? Now, in this case, one idea is that, because this is actually a bit hard to figure out, once you have the values for b and c, you input any point on this graph in this equation. So for example, you have this function now, y equals a into tan of x minus pi over 4 plus 1. That's the function. Take any point in the graph, input that here, the values of x and y at that point. For example, You could write this point here. This is pi over 4 and 1, if that works. Tan of pi over 4. Sorry, this was like this. A into tan of x minus pi over 4 like this. If you input pi over 4 there, that's not gonna work, because pi over 4 minus pi over 4, that will become 0. It will eliminate a as well. So you'll have to take another point. Take another point in the graph, for example. You can take this point. This is x equals pi over 2 and y equals 3. Input this point here, find the value of a from that. That's one idea that will work. Another way to think about this is the original tan graph, it basically goes like this. It starts from 0 and then it becomes 1 at pi over 4. So the value that it has at pi over 4 is equal to 1. So the tan graph, the original tan graph, it moves 1 unit up. It moves 1 unit up as it goes pi over 4 units to the right. It goes 1 unit up in an interval of pi over 4 units. Now, what about this transformed graph? This graph is basically starting from this point, right? How much is it moving in the vertical direction in a distance of pi over 4? This is pi over 4 distance. In this pi over 4 distance, the graph is going up by 2 units. So it was originally supposed to go up by 1 unit. In this case, it's going up by 2 units. So that means the value of a here, it's a vertical stretch. It's a vertical stretch of scale factor 2, right? So the value of a there should be 2. If you understand that, that's good. Otherwise, this is an easier way of doing this in this particular example, that you input a point and find the value of a from that. Okay. All right, let's move on. Just a couple more examples and then we end. Okay, let's have a look at this now. This is from a recent paper, fairly complicated examples. You've got this diagram that shows the curve y equals k cos of x minus pi over 6, where k is a positive constant and x is measured in radians. The curve crosses the x-axis at points A and B as a minimum, and A and B is a minimum point. Find the coordinates of the points A and the point B. Now, what's the function? It's a cos function. And they have shown you what transformation is happening in the horizontal direction already. It's x minus pi over 6. What does that mean? X minus pi over 6? That means the graph is going pi over 6 units to the right. Now, what's the original cos graph? The original cos graph looks like this. It starts from 1, goes to 0 at pi over 2, and then goes on like this. That's what the original cos graph looks like. This is the graph of y equals cos of x. Now, if you move it pi over 6 units to the right, what happens? This point, which was at 0 earlier, that moves to the right, and it becomes pi over 6 here. So the graph moves pi over 6 units to the right like this. And then they're asking you to find this point A. How do you do that? How much is this distance? Pi over 2. So that means this distance from that maximum point to this point, this should be pi over 2. And then from this point to the minimum point, this is another pi over 2. This is another pi over 2. So that's pi over 6 plus 3 pi over 2, and that gives you this point. That's 5 pi over 3. So the value of A, therefore, the coordinates of A, they are 5 pi over 3 and 0. What about the minimum point B? You do the same thing here. You know the point A now. Let's go to the right. It's pi over 2 more here, another pi over 2 here, another pi over 2 here, and that's the point B. So 3 pi over 2 more added to that. That gives you 19 pi over 6. The coordinates of B, therefore, what are they going to be? The x coordinate is 19 pi over 6. What about the y coordinate? The graphs, the function that they've given, it has k multiplied outside. So that means k is the amplitude of this graph. If k is the amplitude, this point is k units below the x-axis. It's k units below the x-axis. So what's that point going to be? That's minus k. The y coordinate therefore turns out to be minus k. Okay. Let's have a look at this example. Similar to that. The diagram shows the curve with equation y equals k sine of half x. The curve has a minimum point at A. Now it's a sine function. Think about the original sine function. What does the original sine function look like? It starts from 0. It goes to 1 at pi over 2. It comes back to 0, goes to minus 1 at 3 pi over 2, and so on. Now, what's the function? It's k sine of half x. You know what transformation is happening in the horizontal direction. Half x. What does that mean? the period becomes double, right? It's a horizontal stretch, scale factor 2. What's the period of the original sine graph? For the original sine graph, the period is 2 pi. For this, the period becomes 4 pi. It's a horizontal stretch, scale factor 2. Okay. They want us to find the coordinates of this point A. Now, the y coordinate, just like in the previous example, is going to be minus k. Why? Because we've got k multiplying outside. So the amplitude is k. So this point here has to be minus k. What about the x coordinate? How do you figure that out? In the original graph, this minimum point comes at 3 pi over 2, right? The minimum point comes at 3 pi over 2 in this original graph. When it is stretched by a scale factor of 2, that gets multiplied by 2. 3 pi over 2 times 2. What does that give you? That gives you 3 pi, and that's the x coordinate of that minimum point. So it's 3 pi and minus k. That's the point that you get there. And then it says a sequence of transformations that is applied to the curve in the following order. Now, this is the curve that you have. They're applying some transformations in that. Translation of 2 units in the negative y direction, that's 0 minus 2. Reflection in the x-axis. Reflection in the x-axis, that's a vertical reflection, right? The y coordinate gets multiplied by y, multiplied by minus 1. And then it says, find equation of the new curve and determine the coordinates of the point on the new curve corresponding to A. So the corresponding to the point A, the minimum point, you have to find the new point. How do you do this now? The original graph looks like this. K sine of half x. That's the original function. What are they doing? Translation of 2 units in the negative direction. What does that mean? You've got minus 2 outside the function. And then that's the first thing that happens. And then they're saying it's a reflection in the x-axis. That's a vertical reflection. So you have minus multiplied with the whole thing. Vertical reflection, minus gets multiplied outside the function. So you multiply minus outside the whole function like this. Simplify that, and that's the result that you get from that. And then what are the coordinates of the point A going to be? Originally, it was 3 pi and minus k. Apply those same transformations on this as well. Translation of 2 units in the negative y direction. Minus k was the original point. You subtract 2 from that, it becomes minus k minus 2 initially. After that, translation, first of all, k becomes minus k minus 2. All right. And then you have a reflection in the x-axis. It's a vertical reflection. You multiply that y coordinate with minus 1. So you multiply with minus outside. That's the second thing that you do. This is the second thing that you do. So it becomes minus into minus k minus 2. And that simplifies to k plus 2. There's no horizontal transformation. So the x coordinate remains the same. That's 3 pi. And the result that you get is 3 pi and k plus 2. That's the final answer that you've got. These are most of the difficult questions that you find in transformations in recent papers. You have these in the notes. Have a look at them in detail, and that should prepare you well for transformations as well. All right, I hope that was helpful. Okay, so remember in horizontal transformation, the rule is you do opposite of BODMAS. Whatever BODMAS says, you say, no, I'm not going to do that. I'm just going to do the opposite of that. This is minus 2 into x plus 4. This is horizontal because everything is happening inside the function, right? So these are horizontal transformations. Now, BODMAS says you evaluate this bracket first. So you do plus 4 first. Plus 4 means translation. But you have to do the opposite of that. So you don't do translation first. You do stretch deflection first. So that's what you do first, and then you do translation after that. So it's just opposite of BODMAS. Right? It's okay. A paper would not have all difficult questions. You'll have like 2-3 difficult questions, 2-3 very straightforward questions, and then 6 average questions. So if you get a difficult transformation question, you'll get some other easier questions. It's okay. It'll get balanced as long as you're prepared well. You can rely on the threshold as well, and of course, duas. Yes, I'll be doing it for all components, inshallah. that's what the plan is. For M1 and S1, at least, I will be doing it. P3, after the P1 experience, I think that's going to take forever to end. So I'm not too sure about that right now. I do plan to do that, but I still have to see how to schedule that. It'll be like 6 hours, 2 days. Let's see what we can do. For P3, can I share the updated quick notes before the worksheet? Well, I thought you knew me from the class that you studied with me at ISL. I do everything at the last minute. So for this class, I was preparing until 4:30. So I told you we will start at 4:15, but we started at 4:30. Why did we start 15 minutes late? Because I was still making these notes. I cannot do anything before time. That's not how I'm built. So that's not going to be possible. They will only be available when the actual workshop happens, because I will keep procrastinating, leave it for the very end, and then it will be made at that time. But I'll try. I say that for everything, but that's what mostly happens at the end. I'll do it at the very end. I will try, however. I'll try if I can do that. I'll share them with you. But the older ones are available, but I'll be adding much more to that from the recent papers. But that will only happen at the end. I can't promise that I'll be able to do that earlier. -4, -4. I can't find that. Was it this? How much more do I zoom out, Amradi? Is that fine? Can you read anything? Okay, whatever it was, just remember this is the rule. This is the rule. Multiple vertical transformations, you follow BODMAS. Multiple horizontal, you do opposite of BODMAS. Okay, that's the rule. So that's the rule that will work. Now, when you have vertical and horizontal both, it does not matter whether you start from vertical or horizontal. You can start from any of them, and that will be fine. But within vertical, within horizontal, you have to follow this order. Yes, Eamon. Eamon, you want to say something? You had your hand raised.
I think it's in the horizontal transformation, Villa. I think इसमें stretch है इसका scale factor जो आपने कहा था कि if it's a like उस function में if it's a then इसका stretch factor will be the reciprocal. So I was thinking if it's in fraction form already like in the function like I don't know like 1/5 or something. So its stretch factor will be 5.
It'll be 5. Yeah. So you just take reciprocal of that. Whatever that number is, you take reciprocal of that. So if it's 2, it becomes 1/2. If it's 1/5, it becomes 5. So stretch factor is just reciprocal of that number. So if it was, for instance, here, f of x over 3, it will be a scale factor of 3. Reciprocal of 1/3. Okay. Anything else, anyone? Any problems? You're all welcome. It was very tiring, but many of you stayed until the end. So thank you for that. That's helpful, and the feedback as well. So we will end this here then. Tomorrow we will be doing differentiation and integration, and we will most likely start around 6:15 p.m. inshallah. Yeah, so they're relatively easier now. We don't have many difficult questions in them as well. Not much variation that you have in past papers as well, apart from just a few questions on differentiation. So they'll be quicker inshallah. So tomorrow, those of you who, okay, I'm sorry. Can you still hear me? Can you guys still hear me? Yes. Okay, so those of you in the past paper session, just an announcement that we won't have that class tomorrow. In place of that, we'll have this revision class, differentiation and integration. Okay, so we on Tuesday and Wednesday then we will have P1 both days. We'll do difficult questions, and then on Thursday it'll be an open session for everyone. I'll be just asking any. I'll be answering any questions that anyone has on Thursday. So tomorrow we're not having the past paper class. That's not happening tomorrow. Uh, that will be replaced with the revision class for tomorrow. Okay. Okay. All right. All right. Thank you, everyone. I'll see you again in the next class then tomorrow. All the best for preparation for the other papers as well. Allah Hafiz. Abdul Rafi, they will be from those assigned papers as we normally do. I'll be posting a poll in the group from those papers. So it'll be from 2023 papers. I think we're done with 2023 papers, or maybe 2022 papers. One of those. We will be doing difficult questions from those, inshallah. Okay, all right. Allah Hafiz. Allah Hafiz.